Hello friends, today we are going to discuss the important concept of linear programming which is mentioned here. So the basic concept of linear programming is a little bit simple, and there are three important components of linear programming, any linear programming problem. The first one is decision variables. So decision variables are those variables or activities which decides our objective and what we want to do and in what manner we want to do. The next one is the objective function. Every problem is some kind of problem and our objective is to find the best solution of that problem. So the second component is objective function, and the third component is constraints. Constraints are those conditions under which we have to find a solution which is best suitable for our objective function and gives the best results. Okay, so to visualize a standard structure of linear programming problem, I have already mentioned a linear programming problem. You can see using graphical method solve. This is the method, our problem, maximize z, and the function is 15x1 plus 10x2. This is my objective function. So what is our objective? Our objective is to find the values of x1 and x2 which are decision variables in such a way so that the following set of constraints should be maintained or they should be followed. So the set of constraints is given as 4x1 plus 6x2, x2 is less than equal to 360, 3x1 is less than equal to 180, and 5x1 is less than equal to 200. So this is our objective function, these are our decision variables, and this is the set of constraints. One more important constraint is that our decision variables x1 and x2 are positive, because whatever the real time problem we are dealing with, this is some kind of problem in which the resources are involved. So any of the resource, it could be time, it could be money, it could be human resource as well, this can never be negative. So this is another important constraint, that the decision variables can never be negative values, they must be positive values. So graphical method is solved by following some steps. This is 3 or 5 or 6 steps in which we have to study the procedure of linear programming solving by graphical method. The graphical method is also called extreme point method. In this method, what we do, we construct a feasible region obtained by the decision variable, constraints, set of constraints, which is followed the given constraints. Okay, and we find the extreme points of our feasible region. Okay, so we start solving the problem. You can see the problem is very clear. We have an objective function which has to maximize under the following, by following the set of constraints. So in step first, what we do, we convert inequalities into equalities. So the constraints which are given in form of inequalities, we convert them into equalities by eliminating or by replacing the inequality sign by equality sign. So after the conversion, the constraints turns as, my first constraint turns in 4x1 plus 6x2 is equal to 360. Second constraint, 3x1 is equal to 180, and the third constraint changes, 5x2 is equal to 200. This is how we convert our inequalities into inequality. We did nothing, just replace the inequality sign by a equality sign. Now, in next step, we have obtained some linear equations. We can label them A dash, B dash and C dash, and corresponding inequalities can be labeled as A, B and C. So we can understand the correspondence between the inequality A and A dash, B and B dash and C and C dash. Okay. The next step, plot the linear equation that we have obtained in step 1 on graph paper. So we are going to try the plot the lines or the linear equation on our graph paper. So as we recall some procedure of drawing some lines on graph paper in 10th class standard, we have learned about the plotting of line. We had studied the intercept form, in which we have an equation of the form x upon a plus y upon b is equal to 1. In coordinate geometry, we have this kind of line, and this was known as intercept form. So what we did to plot this line, first we put y is equal to 0, we will get the x intercept on x axis. Likewise, if we put y is equal to 0, we have x upon a is equal to 1, so x is equal to a. And if we put x is equal to 0, we had y upon b is equal to 1, leads us y is equal to b. So to plot this line, we have intercept x is equal to a on x axis and y is equal to b on y axis. So this is my x axis and this is my y axis. So the line can be plotted as this is x intercept a and this is y intercept b, and the line was this one, denoted by this equation. So we are going to use the same procedure, intercept form of line, and we will use the intercept form plotting with the help of these constraints. Okay? So this was just to recall how we can plot the lines of our graph on our graph paper. So let me know this thing. Now I am going to plot. I am starting plotting of lines. This is my x1, this is my x2. So I consider the first equation. 4x1 plus 6x2 is equal to 360. Put x1 is equal to 0. We had 6x2 is equal to 360. So x2 is equal to 360 upon 6, which is 60. And if I put x2 is equal to 0, I have 4x1 is equal to 360. So x1 is equal to 90. So I have my intercepts on x1 axis and x2 axis. These can point like this. This is my point 90, 0, and this is my point 60, 0, 60. So the line is this 8. So this is how we plot our first line, denoted by this equation 4x1 plus 6x2 is equal to 360, and the procedure or the mechanism of plotting of line is this one. Using intercept form, first we calculate the intercept on x2 axis, and secondly we calculate intercept on x1 axis. Now we plot the second equation. So I need to rub this thing. My equation is 3x1 is equal to 180. So gives me x1 is equal to 180 by 3, which is 60. So x1 is equal to 60 is a perpendicular line or parallel to x2 axis at the distance 60 units from origin. So this will be something 60 this is point is 60, 0, and the line will be this one, B dash. Now I am going to plot the third line, which is that 5x2 is equal to 200. So x2 is equal to 200 upon 5, which is 40. So x2 is equal to 40, a horizontal line which is parallel to x-axis at 40 units apart from origin. So if I put this thing, this is 60, so we can assume 40 here. So my line will be this one. This is C dash. And its coordinates are 0 and 40. Now, we have plotted our lines. In step 3, what we do, we mark the feasible region. This is a very important term, feasible region. Feasible region is the feasible solution region or solution space in which every point is a solution which can be satisfied by the given constraints. But our objective is not to find any solution which is satisfied by the constraint. Our objective is to find the best solution under these conditions and which maximize this function. So this is achieved by using the extreme position coordinates of extreme points. So first of all, I will mark the feasible region, and this is region followed by the given constraint. So we consider the first line A dash, which corresponds to my first constraint A. 4x1 plus 6x2 is less than 360. So this less than sign means the region below the line. So we can mark this region. Okay. Now we move to next equation. 3x1 is equal to 80 correspond to my second constraint. 3x1 is less than equal to 180. So this less than sign means the leftward side. This is what? This region. Okay. And as far as the third equation is concerned, 5x2 is equal to 200, which associates or which corresponds to my third constraint. 5x2 is less than equal to 200. That means the region below the line, third line. So line is this one. In our next lecture, we will discuss in detail how we can mark the feasible region, whether it is left hand side of the line or it is the right hand side of the line. So this we will discuss in our next lecture. Now, I am going to mark the boundaries of my feasible region. This is O, A, B, C and D. Why this is the region? Because O, A, B, C, D is the region which is satisfied all the three constraints that are given to us. Okay? We can write this thing, consider as this is the region, whatever the region, all the points in the region, they are satisfied by all the constraints. If we consider this region satisfies A dash or A constraint, but it is beyond the constraint C dash or C, whatever it is. So this is my region. Okay? So this is the feasible region that we have obtained, O, A, B, C, D. Let me mark here. O, A, B, C, D. Now next step is to find the coordinates of the extreme point of my feasible region. So my extreme points are what? O, A, B, C and D. So what are the coordinates of point O? These are very simple. 0, 0, as this is our origin. Next point A, the coordinates are 60 and 0. Next point B, I will calculate later. What is the coordinates of point C? They are still to be calculated. And what about the point D? This is 0 and 40. Now we are going to calculate the coordinates of B and C. For this I need some space. So what should I erase? I think this thing is meaningless. Now, look, My point B is the intersection point of B dash and A dash. B dash and A dash. So the coordinates of B are obtained by putting or by solving these two equations. So right here 4x1 plus 6x2 is equal to 360 and 3x1 is equal to 180. This gives x1 is equal to 60. Put x1 is equal to 60 in A dash. We have what we have? 4 into 60 plus 6x2 is equal to 360. So what is x2? x2 is equal to 360 minus 240. What is that? This is 120. No. 0 to 120. 6x1 2. So x2 is equal to 20. So the coordinates of B are 60 and 20. So we have calculated B, the coordinates of point B, 60 and 20. Now we are going to calculate the coordinates of point C. So in point C, the equation C dash, we have x2 is equal to 40, which intersect the line 4x1 plus 6x2 is equal to 360. So 4x1 plus 6x2 is equal to 360. This is my line A dash. So if we put x2 is equal to 40 in this equation, I will have 4x1 is equal to, plus 6 into 40 is equal to 360. So 4x1 is equal to 360 minus 240. So x1 is equal to 120 by 4, which is 30. So the coordinates of point C are 30 and 40. 30 and 40. So now I have calculated all the extreme points of my feasible region. The point O has 0, 0 coordinates, point A has 60, 0 coordinates, point B is 60, 20. We can write here. My point C is 30, 40 and my point D is 0, 40. So these are the extreme points of my feasible region. Now these points will give the maximum value of our objective function max z is equal to 15x1 plus x2. So now we are going to calculate the value of z on these different positions or the extreme points. Likewise, ZA is equal to 15 into 60 plus 10 into 0. This is 900. ZB 15 into 60 plus 10 into 20. This is 1100. ZC 15 into 30 plus 10 into 40. This is 450 plus 400, that is 850. Now, what is ZD? Where should I write? let me write here, ZD is equal to 15 into 0 plus 40 into 10 into 40, which is 400. And ZO is 0, because 15 into 0 plus 10 into 0 is 0. So now we have the values of objective function at different extreme positions, points, and we can observe here that the maximum value of Z is at point B, which is 1100, and at the values of x1 is equal to 60 and x2 is equal to 20. So we can conclude the maximum value of Z is 1100 at point B. So the solution is x1 is equal to 60 and x2 is equal to 20 is the optimal solution, which gives the maximum value of Z, our objective function, is 1100. So this is how we can solve a linear programming problem using graphical method. In our next lecture, we will discuss some more problems concerning with linear programming problem, and they will be solved by a graphical method with different set of constraints, with different set of objective functions. Thank you.